Welcome to David Alexander Maths Tuition. This is chapter 3A on arithmetic sequences. Okay, so for arithmetic sequences at A level, we're almost making life much harder than we feel is necessary. If I said to you at GCSE level, what is the nth term of this sequence? You'd probably work it out straight away. We know that we are going up in threes, like the 3 times table. So this is a wonky 3 times table. This number sequence is the 3 times table with 1 added to it. So the nth term is 3n plus 1. Okay, but let's look at it from a different perspective. To go from 4 to 7, we are adding the difference of 3. So I'm going to say that the difference is just d. So to go from 4 to 7, I'm adding d. To go from 4 to 10, I'm adding 2d. And to go from 4 to 13, I'm adding 3d. So 4 plus d is 7, 4 plus 2d is 10, and 4 plus 3d is 13. So our starting value plus the difference gives us the second value. Our starting value plus 2 differences gives us the third value, and the starting value plus 3 differences gives us the fourth value. So this is the second value, 7 is the second value, 10 is the third value, and 13 is the fourth value. And we will see that the number of differences we add is 1 less than the number of terms. Okay, so what we can say is so we've got this formula, which is a plus n minus 1d. That's the formula we use. A is the first term in the sequence, and d is the difference, and the number of differences is 1 less than the number of terms in the sequence. So if un is a plus n minus 1d, if we want to work out the value of, let's say, the 17th term, so u17 is going to be a plus 16d. If we want to work out the 21st term, then that is going to be a plus 20 take away 1, so 20d. So although this formula might seem a little bit more complicated, it will make life a lot easier for us a lot later on, and it's actually quite handy for us just to think of the 17th term is a plus 16d, the 21st term is a plus 20d, and we'll see this in practice later on. So just remember that the nth term is a plus n minus 1d. Okay, so here things are slightly easier again. Find the first terms of 3n plus 7. Well, all we need to do is substitute n is 1, n is 2, n is 3, and n is 4 into this little formula here. So 3 times by 1 is 3, plus 7 is 10. And to be honest, I wouldn't bother substituting into 3 and 4. I would just know that we are going up in 3s, so that would be 13, 16, 19. Negative 2n take 5, so that's going to be minus 2 times 1, so minus 2 minus 5. So the first term is minus 7, and again we're just going down because it's a negative sequence in 2, so minus 9, minus 11, and minus 13. But by all means you could just substitute in n is 2 and you'd get that, n is 3 and you'd get minus 11, etc. Find the nth term and the 50th term of the following sequences. So well, again, you might be thinking, well, I can work out the nth term of this without using these complicated formulae anyway. But we've got the formula of un is a plus n minus 1d. So here our nth term is a, which is 28, plus n minus 1 lots of the difference. So we can see that the difference is minus 3. So what we can do is just expand this out. So that's 28. If you imagine the minus 3 is at the front of the bracket, then that's going to be minus 3n plus 3. And 28 plus 3 is 31. So it's minus 3n plus 31. You may well have been more than comfortable just knowing that this is like the wonky minus 3 times table. So we're comparing minus 3 to 28, minus 6 to 25. So it's going to be minus 3n. And what do you do to go from a minus 3 to a 28 or a minus 6 to a 25? Well, we are adding 31. But you might want to start using this un equals a plus n minus d formula. So the 50th term, Probably the easiest thing to do is just substitute 50 into the formula. So that's going to be minus 3 lots of 50 plus 31. So that's minus 150 plus 31. And yes, I'll use the calculator for this. 31 minus 150 is minus 119. There we go. Okay, so again, this could have been a GCSE question. You might know straight away what the nth term is for this, but let's use this new formula of un is a plus n minus 1d. So a is 11, the difference is plus 5, so that's going to be plus 5 lots of n minus 1. So that's 11 plus 5n take 5, so that's 5n plus 6. Okay, so that is the formula. We need to work out the formula before we work out the number of terms. So we know that this sequence goes up to 2, 3, 1. So what is the value of n? Remember, n is the number of terms in the sequence. So I'm going to make this equal to 231. So 5n plus 6 equals 231. So therefore 5n is going to be 231 minus the 6, which is 225. So therefore n is 225 divided by 5, n is 45. So this is the 45th term in the sequence, and since that is the final term in the sequence, then there must be 45 terms in that sequence. Okay, so here we've been told that the first term is 17, so a is 17. Now this is what we need to remember, the fifth term. Now the fifth term is a plus 4 differences. Okay, so this is really handy to remember. The fifth term is a plus 4d. The 20th term would be a plus 19d. The 52nd term would be a plus 51d. So what we can say is that a plus 4 differences is 29, and we know that a is 17. So 17 plus 4d is 29. So therefore 4d is going to be 29 take away 17, which is 12. So d is 3. So the common difference is 3. Okay, so what is the value of the 100th term? Well, we don't actually know what the formula is, but the 100th term is a plus 99 differences, and we know that d is 3. So, and we know what the first term is, 17. So 17 plus 99 lots of 3. So 99 multiplied by 3 plus 17 is 314. So that is the value of the 100th term. So just remember the 100th term is a plus 99 differences. Of course, we can only use this if we actually know what a and d are. So here we've been told that the nth term is un plus pn plus q, okay, where p and q are constants that we're going to work out. So the fourth term is 30, the seventh term is 50. So if the fourth term is 30, that means a plus 3d is 30. So the first value plus 3 differences is 30. And for u7, that is the first term plus 6 differences is 50. And what we've got here are two simultaneous equations. So I can subtract one from another. So I'm going to get 3d equals 20. So here d is 20 over 3. And since d is 20 over 3, I can work out what a is. So a plus 3d is 30. So a plus 20 is 30. So a is 10. Okay, so I've worked out d and I've worked out a. So remember the nth term is un is a plus n minus 1d. So that is 10 plus 20 over 3 lots of n minus 1. So that is 10 plus 20 over 3 n take away 20 over 3. So I'm running out of space, so I'll just stick it over here. And 10 take away 20 over 3 is 10 over 3. So it's going to be 20 over 3n plus 10 over 3. Okay, so now we've got the nth term in the form of pn plus q, where p is 20 over 3 and q is 10 over 3. Okay, so here we need to find the first negative term in the sequence. So what we need to do is work out the nth term. So we've got some clues. U4 is 41, so that means a plus, so the fourth term is the first term plus 3 differences. So a plus 3d is 41. and the sixth term is 33, so that is A, the first term plus 5 differences is 33. Okay, so I'm going to subtract one from another. I'm subtracting going upwards, so 2D is 33 minus 41, which is negative 8. So D is negative 4. Okay, now I can work out A. A plus 3 lots of negative 4 is 41. So A take 12 is 41. So A is going to be 53. There we go. Now, so UN is A plus n minus 1D, which is 53, minus 4 lots of n minus 1. I've just put the D in front. So that's 53, take away 4n plus 4. So the nth term is minus 4n plus 57. So how do I find the first negative term in the sequence? Okay, well, I could just do trial and error, but the best thing to do is make our formula, instead we're not going to make it equal a negative value, we're just going to make it equal 0. So is there an nth term? Sorry, is there a term in the sequence that is 0? Probably not, but let's see what happens. So negative 4n equals negative 57. So n is negative 57 over negative 4. So n is, well, it's the same as 57 over 4, which is 14.25. Now, remember that the letter n corresponds to its position in the sequence. Well, you can't be in a position of 14.25. If you're queuing for some Iron Maiden tickets, either you're 14th or 15th in the queue, you're never 14.25. So the 14.25 term, which doesn't exist, gives us 0. So it's going to be the next one after it that will give us the first negative term. So therefore n will be 15th. It is the 15th term that will generate that first negative sequence. We can test it if we like. The 14th term will be positive. The 14.25th, which doesn't exist, will give us 0, but the 15th will be the first one that gives us a negative value. The first three terms of a sequence are 2p, 3p, and 16, where p is a constant, and we want to find the 16th term. Okay, so this question is actually much easier than you think. So it's an arithmetic sequence. Probably should say this arithmetic. So we've got the first term 2p, second term 3p, and the third term 16. So whatever I'm adding to 2p to 3p, that is the same as what I'm adding to 3p to make 16. So the difference between these two terms is the same as the difference between these two terms. So in other words, 3p minus the 2p, that is the same as 16 take away 3p. So 3p take 2p is 1p. So p is the same as 16 take 3p. I'm going to add the 3p to both sides. So 4p is 16. So therefore p is 4. So the sequence will go 2 times p, which is 8, 3 times p, which is 12, and then 16. So I'm going to work out the nth term. So the nth term is un equals a plus the n minus 1d. Again, this formula seems a bit of overkill for this one. So it's 8 plus 4 lots of n minus 1, which is 8 plus 4n take 4. In other words, 4n plus 4. So when n is 16, that's going to be 4 lots of 16 plus 4. 4 16s are 64, plus 4 is 68. So there we have it, the 16th term is 68. So with this sort of question, just remember that we can, because it's an arithmetic sequence and the differences are constant, we can say that this minus this is the same as this minus that. And here's one last example, very similar to the previous one. The differences are the same because it's an arithmetic sequence, so therefore we can say that k squared take away 12 is the same as negative 5k take k squared. The only difference here is we're going to end up with a quadratic, so I'm going to move all this stuff on the right to the left to make it equal 0. So that will be 2k squared plus 5k take 12 equals 0. So I'm going to use my quadratic equation solver on my calculator. 2 plus 5, negative 12, and I'm getting k is 3 over 2, and also k is negative 4. There we go. And we can also sort of substitute them in if we want, and we can see that these arithmetic sequences do work. In fact, let's test it with the easy one, negative 4. Negative 4 squared is 16. Minus 5 times minus 4 is 20. So yeah, that we are plus 4, and of course if we substitute in 3 over 2 we can see that we would also end up with this adding the same difference from the first to the second and from the second to the third.